of this tutorial is creating a level So with that clear, we can proceed with the last part. The last part of this tutorial is creating a level and polishing the game. I don't want to invest too much time in creating a level because this is not exactly a game design tutorial, excuse me, a level design tutorial. So what I'm going to do is, with my programmer powers, try to make it a little bit more nice. We will use this same track, and if you wish to modify the curves, you will see that this track is a spline, and this spline we can modify it if we go to landscape, and here we can select our splines. So you could modify it if you would like, but in my case I'll just make it look a little bit prettier. For now I will get rid of most of these checkpoints. Let me return to my select mode, and now I should be able to select the checkpoints, and here they are. I will get rid. So you could modify it if you would like, but in my case I'll just make it look a little bit prettier, a bit more nice. We will use this same track, and if you wish to modify the curves, you will see that this track is a spline, and this spline we can modify it if we go to landscape, and here we can select our splines. So you could modify it if you would like, but in my case I'll just make it look a little bit prettier. For now I will get rid of most of these checkpoints. Let me return to my select mode, and now I should be able to select the checkpoints, and here they are. I'll select all the checkpoints and delete them for now, just for now. Now I want this straight part of the track to be the last part of the track, so the end is like a high speed straight, something like this. So I will put a checkpoint here, and I'm using Ctrl P and searching for the checkpoint, and I'm going to drag and drop it to the map. And what happened? Let me do it again. There it is. And it should be here. Yeah, perfect. Now I want to replace this material because I want it to be a little bit more realistic. given that our car is a little bit more realistic, right? So our replay, there it is. And it should be here. Yeah, perfect. Now, I want to replace this material because I want it to be a little bit more realistic, given that our car is a little bit more realistic, right? So, as I said before, this will be the last part of the track, so I'm going to move this player start to the new beginning. The player start is how the game mode will decide where to spawn our default pawn, which in our case is the car. So this player start, wherever it's pointing to, my car will also be looking there. And I know that this player start has some scale change to it, but you could delete it and add another player start. It's in basic, player start, and right now it says bad size because it's colliding with the floor, but once we do that and I'm pressing the end key here to snap it to the track, now it's the same, but I'm gonna stay with the one that was already in the map. If you have more than one player start, then it will be random the place that the game mode will choose. So with that, let's change this material. And for that, I'm going to add assets from the Quixel content. Here in the bridge, I have already saved. Here I should have local, or let me filter it by the hearts that I put in some of these assets. Oh, and I'm not seeing the hearted assets, my favorite assets, because I have not signed in. Let me sign in, I'll pause the video, and we should be back here. Now I can see the assets that I already favorite. Now remember that when you add, when you log in with your Unreal account or your Epic Games account, you are able to use any of these assets here for free in any of your Unreal Engine projects. So I'll go to favorites, and I already have some first surfaces. I have this asphalt road and this damaged concrete that I already downloaded. I'm using the medium quality. I didn't really feel the difference with the high quality or highest quality. Medium quality is fine by me. So I'll just select this asset. Let me go back to favorites. It's the asphalt road and the damaged concrete. Let's import it, and again, and now we have these two folders. Now for the asphalt, well, let's use the asphalt road. Here we already have a material, so let's just drag and drop it. There we have it. And for the sides, we will use the other material, the damaged concrete. And there it is. We have now
Built to help you develop skills that you can apply right away, Google Play Academy offers
the the new track with the new materials. We have now the new track with the new materials, right? I also wanted to change this floor. I'm going to use a little bit of vegetation, so maybe some dirt or something like that that I can add to this floor. For that floor, I'm going to go back to the bridge, surfaces, and I added this one called forest floor. And well, I'll download it. Again, medium quality. I don't really need more than that, and export it. Now we have it here, and I'll just drag and drop it on the floor. Now, if I'm not seeing it, it's because this floor, it's a landscape streaming proxy. So I need to select the landscape and change the landscape material. And I can open this material. And we can here change the surface floor, grid color, etc. So this will make us create a new material. Well, yeah, a new material for this specific landscape. So let's do that. Let's go to our racing game. Here we can add the new folder material. Let's call it racing landscape. Because I don't want to have to deal with the roughness, I'm not going to create a complex landscape material. And now I'm going to drag and drop the textures that I will be using for this. In my case, drop complex. Landscape material. And now I'm going to drag and drop the textures that I will be using for this. In my case, where is my Megascan surfaces, forest floor, and here we have I'll probably just use the normal. Not so much of this other material. Yeah, let's keep it really simple. Let's start by adding the layer. Blend. And this is not the one that I was looking for. This one is called Landscape Layer Blend. This is the one. For now, I will only have one layer, which is the dirt. Let's call it dirt. This is the one. For now, I will only have one layer, which is the dirt. Let's call it dirt. Connect this to the base color and connect this one to the normal. Let's just put it like this. Save it.
Today I'm going to show you guys the difference between using a regular mouse and
now let's apply it to my landscape. Select the landscape. Oh, and I'm going to here go back to the material, browse to it, and create a material instance. This will be MI Racing Landscape. Just so if we manage to add some more properties here, it's easier and faster to change. And now here, in the landscape, let's add the material, which is the MI Racing Landscape. Now, I'm not seeing anything because I need to go to the landscape, and here in Paint, I do need to create this layer information. So let's create the layer info. And I would need to create this one. Weight blended layer. Just select the default folder, dirt layer info, and now we should be able to see it. Oh, and it's entirely my bad, because here in these landscape pieces, we have not set up the correct material. So that's the issue, right? We have not set up the correct material. So that's the issue right now. Let's select the correct material. Now we should be getting the information that I was looking for, which is this material that it's looking very nasty right now. So I need to, here in the material, mess around a little bit with the coordinates. And that's what I'm going to do. For that, I'm going to get the absolute, nope, it was the world position. This is the one. I remember it was absolute something. With this world position, I only need the X and Y value. So let's add a mask here. And I just want the component mask, this one. So I'm getting the X value R and the Y value G. That's the only thing I need for these coordinates. Now we're going to do a little division. And the value here will be one constant, or just a constant one vector. You can also press 1 and click, and it's the same. And I'm going to convert this into a parameter. Convert to parameter. This will be the dirt tiling value. And by default, I want it to be 512. And I will divide this position by this number. And I'm going to connect this to the UVs. So now you can see the result of what we just done. And I need to do the same for the normal. So they match. Now they should be matching. Now let's save. Let's go back to the map. Let's get out of this landscape mode. And we can see that it's no longer tiling so badly, but we do need to up that number. So here in the racing landscape, let's browse to it, and now open this MI racing landscape. I'm going to have it as a floating window, just so we can click here on the dirt tile value. And now I can see the result of for the normal out of this landscape mode, and we can see that is number. Browse to it, and now open this mi click here we would like it to be. Now, it won't matter if we can see it from this eagle's eye point of view, but if we press play and we are playing, then we shouldn't be able to see it that easily. Maybe it was 512 multiplied by 2, and that's more than enough. I'm using values that are the power of 2 just to keep the textures consistent. And again, doesn't matter that I'm seeing the way it tiles, because we won't be able to see it while we are in the car. It will be very hard to do that, especially when we add more stuff to the track. Perfect. Now let's continue with the level decoration. For the level decoration, I will need more of this bridge, well, Quixel assets. So let's just close the material for now. I don't really need it. And I will be using these concrete barriers, or maybe even these ones. Yeah, I'll add both. Yeah, both. Yeah, both. So let's close the material for now. I don't really need it. And I will be using these concrete barriers, or maybe even these ones. I'll add both. Yeah, both. Yeah, both. So let's add. There's one. And again, add, and there's two. I already downloaded them, so it is easier for me to them. You don't need to see me download them. So now we have this concrete barrier that first I want to add some collision to them. Right now, if I see the collision, I just double click. This is the static mesh editor. We can click here, show simple collision, and there is none. So I want to add a box simplified collision. Yeah, that's all I need. And here at the right side, let's see the collision setup. And right now it's blocking everything and the project's default, which is fine. I'm going to save it and also going to open the other concrete barrier and do the same thing. Here, I know it doesn't have a collision because this remove collision is grayed out. So I'll just box simplify collision. Should be fine. If you needed more something that fits your shape, well, you can delete the collision here, remove collision, and play around with these other settings. Yeah, that's a way that you can make it fit a lot more. But if you have more tangents, more faces, then the computer needs to process more stuff, so I only need a box collision. And in order to feel like I'm colliding with this, it's more than enough. Let's save. And what I want to do is with this one that has a arrow, I want to put them in the corners. That way, when I press play, I have something to collide with. Yeah, and if I add some trees later on, then I don't need to worry too much about the collision with the trees and all that stuff. I only need to worry about the collision of these concrete barriers. So a way that we can do this is, well, we can manually add the concrete barriers. And where's the other one? Oh, and for sure they are too small. Let's play and check out the... Oh, where did I add them? Oh, there. Okay. I can right click, play from here, and there they are. Yeah, they are definitely too small. This one, maybe twice the size, would be nice. Here, scale. I'll put the lock on it, so when I press 2 here, then it scale uniformly. And here too also. Yeah, twice the size is fine. Maybe here 2.5, 3 times. Yeah, that's a lot better. And we could start doing something like this in order for our level to be created, right? If I do that, eventually I would have covered all the things in my map, all the corners, all the tracks, right? But yeah, it could be very time consuming. So we're gonna create a little tool that will help us decorate this level with this type of barriers. Let's go to my racing game environment. Let's create a folder called barrier tool. Inside it, I will create a blueprint class. Barrier environment. Let's create a folder called barrier tool. Inside it, I will create a blueprint class. It's going to be an actor because these barriers are actors. This will be a blueprint barrier tool. And inside it, I'm going to create a blueprint that will help me just create straight lines. This is going to be like a first example of what you can do with blueprints to help you create a level faster. So I want to create a mesh here. I want to be as optimized as I can at the start, because optimizing afterwards gets really troublesome sometimes. So if I duplicate a lot of these components, having a blueprint that holds maybe 50, hundreds or thousands of components will be very heavy. For having a blueprint that holds maybe 50, hundreds or thousands of components will be very heavy for any type of machine. So instead of doing that, we have another component called instance static mesh. And this component, I'm going to delete the other one, this static mesh. This static mesh you can select any static mesh, for example, our concrete barrier, and you see that we are not seeing anything. But it's because we can add instances of this barrier. Now, I don't remember if I can add manually here, rendering instances. Here it is. And it is an instance of this static mesh. And whenever we create another one and we move it around a little bit, let's just put 100 or something like that. Then, as you see, we are not creating another component. This component is in charge of dealing with the creation of another mesh. And we can drag and drop it to our map, right? Now, if I remember correctly, this should have collisions, and we can test it if we play from here and just try to collide with it, and they do have collisions. So now we only need a way of adding more and adding them in the correct scale. So let's fix the scale first. Let's go back to the barrier tool, and we can close this static mesh editor. In this barrier tool, in the instance static mesh, I'm going to change the scale here. Remember, this one was 2. But keep in mind that if we change this static mesh for our other concrete barrier, then it won't match. So for now, let me just revert this, and we are going to create a variable called scale. And this will be a vector because you can scale it in X, Y, and Z. Now we will go to the construction script and we're going to drag and drop this instant static mesh. We first want to define which static mesh we want to create. Here is defined like this, but we should be able to change it. So let's set static mesh, and I'm going to make this new mesh a variable. And let's call it mesh to spawn. Guys are the same as clicking here, instance editable. And this will let me, let's compile, save, that here in the barrier tool, right now that instance, where is my blueprint? Right now this mesh to spawn is none. So I'll just put the barrier there, compile, save it. And now we can see it. If we select our blueprint, if I can manage to select it, here I can search blueprint barrier tool. It's this one. We can change it here also. And we want to do the same thing with the scale. So let's go back to the barrier tool with also. Yeah, it's this one. We can change it here. Way of adding more and adding them in the correct scale. So let's fix the scale first. Let's go back to the barrier tool and we can close this static mesh editor. In this barrier tool, in the instance static mesh, I'm going to change the scale here. Concrete. For now, data will be a vector because you can scale it in X, Y, and Z. Now we will go to the construction script and we're going to drag and drop this instant static mesh. We first want to define which static mesh we want to create. Here is defined. Like this, set new mesh a variable. And let's call it mesh to spawn. I'm going to make it instance editable. These eyes are the same as clicking here, instance editable. And this will let me, let's compile, save, that here in the barrier tool, right now that instance spawn, you can see, barrier, we can, with the copy and paste this, set scale, and we can use this set relative scale. It's the same as clicking here and changing the scale here. So let me just, new scale will be the scale. By default it will be 2. Right now it's 0. Let me put 2, 2, 2. Compile, save, and now we have the scale here. And I did not want to click here. Let me click on the barrier tool again. Right. Here we are in the barrier tool. We can change the scale independently and it should work. Right, so now I don't want to add manually these barriers, right? I will go to the barrier tool and here in the instance static mesh, I'm going to remove the current instances. Maybe I'll leave one, maybe just to see where it's being created. And let me replace this mesh to spawn with the other barrier. So yeah, this is the one that I wanted. So here, I'll just go back to the construction script, and the construction script, I just realized I didn't explain it, is part of the script that will run before the game runs. Before anything here in the event graph is executed, this construction script will run. Not only that, it will run every time any property in my game, well, excuse me, in my blueprint, in this blueprint, changes. So I'll just put here a print. This says hello, right? I'll compile, and if I just hop back quickly, it will print hello. If I move the location, it should print hello, and we can see the log here, hello. I'm not seeing it in the screen because, well, our game is not running, right? But I'll just clear this log I'll move this around and we should have a lot of hellos. I'll clear it again. I'll select again my barrier tool. I change this scale maybe by 3. And this construction script is running because a property changed. And with that said, it's time to create the number of barriers that I will need. First, I need the distance that I want to use to create these barriers. So I need an endpoint and a finish point. I said an end and a finish. I need a start point and an end point or finish point. The start point is, well, this one. It's just fine as it is. So I'll just create another vector called end point. This vector will also be instance editable, and I will put here show 3D widget in the details panel. Compile and save. This where show vector will also be instance editable, and point. This vector will also be instance editable, and I will put here show 3D widget in the details panel. Compile and save. This will let us see that there's here an endpoint, and if we click on it, we can move it around. So we can define our endpoint. Now with this, we can create the logic that can help us spawn the needed barriers. Let's go back to the blueprint. Let's go back to the construction script, and this is where the magic will happen. So let's do some magic. We first need to create the instance mesh, just like we did before. Here, instances, add one, and we will be able to see more instances. So we do need to grab again our instance static mesh, add instance, and you also have add instances, but for our case will be just add instance, and we'll just put it here. This asks us for a transform, and it could be in workspace, but our endpoint is in relative space. So if this is maybe, I don't know, 300, it means that our initial point here is, well, this part. And 300 in X would be, where's X? Here's X. Add instances, but for our case, will be just add instance. And we'll just put it here. This asks us for a transform, and it could be in word space, but our endpoint is in relative space. So if this is maybe, I don't know, 300, it means that our initial point here is, well, this part. And 300, something in it. Now we need a transform, and for that, we do need to make one. Make transform. And a transform is a location, a rotation, and a scale. Scale will be fine because we are already changing the scale here in the instance static mesh, so let's not worry about that. But we do need the location and rotation. And just by doing this part of the code, we can compile and we will see that we have an instance here. Now, let me just remove the instance, where is it, that I added first. And right now we have two instances, one that it's being added by the construction script and one that we added manually here. The way that I'm going to show this is just by rotating the instance that we're adding towards the location of my endpoint, right? And to do that, I first need to use a node to get this rotation, and this node will be the find look at rotation. Now let's remember that we are in relative space, so the start will be the 0, 0. I can make this a literal, where is it, literal, so the start will be the 0, 0. I can make this a literal, where is it, literal vector. No, don't want to. Or I can just right click and split and we will get the vector 0, 0, 0. The target is the endpoint, so let's just connect it like this. Come on. There it is, endpoint, connect it like that. By doing this, if we compile and save, wherever we move our endpoint, our mesh will rotate with it. So now we can see that we have an extra instance that, well, it's the instance that we were adding manually here. This one, so let's just remove it. Compile, save, and there it is. Now, every time I move around, well, I move my endpoint around and we have the space needed to create another one, well, I want to create another one. To do that, we need to execute this code as many times as we need. So how will we know how many times do we need to execute this code? Well, we first need to know our mesh, it's not distance, our mesh length. So for example, if I go to the mesh I selected, which is this one, we can see the approximate size here, and it says 304. So we're going to use that, and I know is that because it's the larger number, and this so how will we know how many times do we need to execute this code? Well, we first need to know our mesh, it's not distance, our mesh length. So for example, if I go to the mesh I selected, which is this one, we can see the approximate size here, and it says 304. So we're going to use that, and I know is that because it's the larger number, and it's very easy to recognize which one is the largest number, which is X. So I need to save that somewhere. I'll just create a variable, because remember, the mesh can change in distance, or in length, or in width. So I'll just put width. And this is not a vector, this will be a float. Let's compile and save. Here in the width, we can type this, and this is float. Let's compile and save. Here in the width, we can type the same value, which is 304. Here it is, and be done with it. Now we are assuming that we are using the X value. If you would want to make this a little bit more automatic, we can get this mesh to spawn. We can get the bounds, and inside the bounds we can split this. We can get the box extent, and the box extent in this case will be half the value of whatever you're seeing here. So you would only need to multiply by 2 and you will get the approximate size. Why am I not doing it like this? Because maybe our mesh, instead of being instead of using the X value, maybe I want to use another one. So that's why I'm not using this type of implementation. That would require for me to content curate the meshes that I'm going to use, but in my case I'll just set it up manually. I only need to check a number, and I only have 2 meshes that will use this. But so with this width sorted out, we can now check, right? And first we need to know the distance between the starting point, which is 0, 0, and the endpoint. So we can check how many instances do we need. So for that, what I would need to do is the endpoint minus the start point, and then I would get the length. That way, if our point is here and our endpoint is here, by subtracting I'm only getting what I need, which is this. In my case, the 0, 0 is the start point, so I don't need to subtract anything. I only need to get the length, so I know the value of this distance. And I should probably use another letter. For example, the distance is this endpoint. get vector length, and with this I need to this endpoint, so I need to, I'll just copy and paste this endpoint, get vectors. I need to divide it by the width of my mesh. Why? Because, well, I already point total distance by the width, then I should be able to get the number of meshes that I could spawn. Now, this is giving me a decimal value, which means that if I have a space for 2.5, it will return 2.5. But I only need integer numbers. So I'll just do a floor operation. The floor means that it will round down the number. If this was 2.5, it will round down to just 2. So now I know how many times do I want to run this add instance. Okay, so let me just move it to the side. And whenever you want to repeat some code, you will be using any type of loop or while operation. In my case, a for loop is more than enough. And here it is, for loop. And now if I connect it like this, it will run the number of times that I say so. Now, right now, this is 2. If I put the first index at 0 and last index at 2, we are not running this 2 times. Because the 0 is the first element, we are running it 3 times. So we will see what happens. I will later on change this to 1. But first, let's see what happens. Compile. And right now, seems like it's the same, but it isn't. There are 3 instances here. Times. Operation. In my case, a for loop is more than enough. And here it is, for last index at as 2, we are not running this 2 times. Because the 0 is the first element, we are running it 3 times. So we will see what happens. First seems now I need to change the location per instance. So the first time it runs, I want for the location to be, well, at the start, so 0 is fine. But the second time it runs, then I don't want the same location, so I need to make some adjustments. The first issue that I need to address is the rotation, because just by adding the width of this mesh to one value, maybe X or maybe Y, won't solve that I want this location. It will probably give me this one or this one, and I want the one in the middle. So to do that, we already know the rotation that we are using for our meshes, so I'll just find the forward vector of this rotation. How will I find it? Well, just get forward vector. With this, now I can multiply the distance, and it will give me that distance in the correct direction. So to just do it, and we will later on fix it a little bit, we will just get the width, multiply it, by the times, get the width, multiply it, do it, and we will later on fix it a little bit, we will just get the width, multiply, find the forward vector of this rotation. How will I find it? Well, just get forward vector, the direction, do it, and we will later on fix it a little bit. We will just get the width, multiply it by the times that we have here, and this is interchangeable. I can just connect it like this and it will still work. So for example, the first iteration is 0 width, so it's stay in the normal place, in the starting point. Iteration number 1 will be width times 1, so it will move the width of our mesh, and so on and so forth. This will be multiplied, and I need even more space here, by the direction. And this direction is the forward vector. And now we can connect this to a location because we have multiplied a scalar value, a number, by a direction, which is a vector. And that gives us a vector with the magnitude that we wanted. The magnitude is how big the vector is. Okay, so let's compile and see what happens now. And this is what is happening. We're getting our endpoint, and when we move it around, the values change. Now, why is it not an exact fit? Well, because our scale has changed. Let me put the scale back to 1. And now every time it has space, it's created. And we have another issue, right? Because I'm creating one at half the point, at half the value. There shouldn't be any space here. And if this doesn't kill you, you can leave it there. To me, it's like, oh, it's not exact. I can forget about it, but right now I would really like to fix it. But it would get a little bit more confusing, but still I'm going to do it just to give the complete knowledge. Okay, so first thing first, let's address the scale, because I want to use to scale everywhere. So I need to take that in consideration. Here, when we are determining how many instances we want to create, how many loops should this have, I need to take in account the scale. So before I get the length of this endpoint, I need to scale it up to the proper value. So let me move this here. So to do that, I'll just put endpoint and divide it by the scale. And here we have the scale. So if it's twice the size, then I'm just dividing it by 2. Something like this. Now with that, let's compile and save. The scale should be working scale and value. So let me move this here. So to do that, I'll just put endpoint and divide it by the scale. And here we have the scale. So if it's twice the size, then I'm just dividing it by 2. Something save doesn't look weird. Like creating one, like bothers me a little bit, so it's a quick fix. Let's go back to the barrier tool. We already fixed the scale. We just need to fix our distance problem. To do that, here, before we multiply this width to our forward vector that I'm going to put like this. And move it to the side. What I want to do is subtract some value like this. And this issue is happening because the pivot point of my mesh is at the center. So I need to take that into account. Here, I will get the width and I will divide it by 2. And I'm going to subtract. Like that. And let me put this here, just width. We have the space for it. It will be created. Now, again, we have a little issue. Because when we do not have space for it, 1 is being created at the 0 point. So again, we have an extra iteration. And that's one of the and select our endpoint and it will work regardless of the changes that we did. And now it's a little bit more intuitive. Now I do not like this gap, and that's why I didn't want to change the width. I mean, I didn't want to use the width that I got from the bound box or the bounding box, because now I can tweak this like I want. So 209 is a fine number, so let's use it. And now what I need to do is, well, look around where we have these straight lines and just move it around. Now we will do something for the curves, don't worry. But for now, this has let us create more easily the barriers for straight lines, and we can tweak around the value scale 3, 2 and 3, this one. If I click on the meshes, I'm clicking on the instances. I can click here on this little icon, or just click it this and create these traits of all those parts of the track. And it's very simple. You just need to for example, get this actor, and let's say that this part is a straight part, then you can just move it here, change the endpoint, and you're done. So I have done that for, well, all the parts that my track has that are straight. In this part, because it's a time trial, this is the end. So you need to check it out as is the finish line, put it at true. And because we're starting here, when we press play, we have this barrier that doesn't allow us to skip stuff. So that way, when we just go around the circuit, and let me just cheat a little bit, then we will be here at the last straight, full gas, and then I win. So pretty cool, pretty cool. We will disguise this some way or the other, and also we will hide this, but right now we have a good start of our map. Now we need a tool for the curves, and for that we're going to use splines. We are also going to use the construction script for that,